All right. Um, so, um, Welcome to the tech drop in for this week. We've got a couple of people on LinkedIn as well as Zoom. As I mentioned a couple of minutes ago while we were setting up there, we don't have a second person on for the Q&A via chat. So best option, if you've got any questions along the way, is to throw them into the Q&A panel if you're on Zoom. We'll post them in the comments section on LinkedIn, and we'll get them copied over. And after the demo, we'll come back and read through and answer any of the questions that might be waiting. So the topic for this week's tech drop-in is data center interconnectivity, or DCI. So basically that, as the name suggests, is connecting between data centers. So basically what we'll do is we'll run through a little bit of a very quick kind of overview of network as a service itself and kind of Megaport to set some context. Then we'll go into some options for data center interconnectivity. So how you can use Megaport to connect together your different data center environments and how that is sort of part of the solution. So often that can be overlooked and kind of seen as something totally separate to network as a service. A lot of people come and look at network as a service in the context of cloud connectivity or global WANs and other bits and pieces, and kind of forget that you can really easily use it for data center interconnectivity. And then you can have this one solution that can cover multiple different use cases. We'll run through a couple of different approaches to that. So things like trunking multiple VLANs or multiple VXCs and QinQ and things like that. And then we'll run through a demo. So basically jump in the portal and deploy some of the resources that we've spoke about. And then at the end, we'll come back and have a look at any of the questions. So to set some context, network as a service basically is the idea of having network services available in the same way that you would probably be used to working with compute services from cloud providers. So Megaport's built this large global private network, and we basically allow customers to deploy services over the top of that network in a very cloud-aligned way. So scalable, elastic, and on-demand, and API-driven, and all those kind of things you're used to when working with cloud providers for compute, we're trying to provide for network services. So that's kind of contrary to what you might be used to with traditional telcos, with kind of long delivery times and builds and long contracts and rigid services. The idea with this is it's more of that cloud-aligned model where you can connect to this network and then you can bring up and down and modify and build whatever you need it. So this relatively busy diagram basically tries to show all the different types of connectivity that you can build out. So this isn't an example of any particular network, and it isn't really a design that you would build as such. It's really just to show an aggregation of all of the different ANs and BNs, all the different places you can create connections to and from the different types of Megaport services and how they plug together. So in a really simple example, at the top left there, you might have a data center where your equipment's there in Iraq, and you might have a port from us delivered to that data center that you're connected to. From that port, you might create a VXC off to the cloud, so straight across the top. And that might be it. But then you might also have another VXC that connects to another cloud. You might have a VXC that goes off to an internet service or connect to our IX. Or maybe you have a Megaport cloud router, an MCR or an MVE deployed in the middle of that because you need to add some routing or some firewalling capabilities. Maybe you don't have a data center at all. You can kind of combine any of these pieces however you need to. So what we'll be looking at today is this section here on the left-hand side. So basically connectivity between two ports in two data centers. So maybe you've got multiple DCs for some reason. Maybe you've got a primary and a secondary, or maybe you've got your main DC in a DR location. Maybe you need to serve content to users in different geographic areas for all kinds of reasons, performance reasons, or could be data sovereignty. You know, there's heaps of reasons why people might have data centers, multiple data centers, either in the same location or different locations. And we're going to have a look at this section here where you're basically connecting from one data center to another. So to start with, this is really the most basic and fundamental way you can do it. So you put a port in one data center on the left-hand side here, put a port in the other data center on the right-hand side, create a VXC between them. And now you have private point-to-point layer 2 connectivity between your two DCs. You get all the stuff you would normally get as far as the network as a service architecture. So you can have flexible bandwidth, from 1 meg up to 10 gig. In some locations up to 25, in a few locations up to 100 gig per second now, and you can change that speed up and down whenever you need. There's an API available as well, so you can automate all of these processes. As you can probably imagine, if you're changing the speed of that link. So for instance, let's say that you've connected your two DCs together. Maybe one's in Brisbane and one's in Sydney, or Melbourne and Perth, or Adelaide and Auckland, or Singapore, or Hong Kong, or wherever, or New York or London, doesn't matter. Wherever they are, the process is exactly the same. The workflow is exactly the same. So all of this applies no matter where these DCs are, and no matter how close together they happen to be or how far apart. So let's say you create this link, you've connected your DCs together, you've got this point-to-point layer 2, SLA backed, all the other stuff, service. But, maybe you need, during business hours, maybe you need 5 gig per second between these sites. Maybe after hours, you only need 1 gig per second. And maybe over the weekend, you can get all the way down to 100 or 200 meg per second. So you can change the speed of this link at any time, and then the cost savings will reflect that. So you only pay for what you have provisioned. And if you don't need a link to be at a particular capacity at a particular time, you can just drop the capacity of the link down to what you do need. And you can do that on and off whenever you need. So you can kind of right size the link and schedule it to be the size that you need at particular times. As you can probably imagine, that's, you can do that through the portal, but it's probably not practical, especially if you're doing it very frequently, to have someone making those manual changes. So we also have an API available, so you can automate that whole workflow. You can hit the API to change the speed of a link up and down. You can pull state and metrics and things like that from the API to integrate with your own monitoring solutions and things like that as well. Sometimes we have customers who hit the API based on a schedule. So maybe they, like I mentioned before, maybe they want a particular speed during business hours, a particular speed outside of hours. Maybe they also need to spike it up to 10 or 25 gig per second for a couple of hours on a Friday night for their backup window, something like that. Another approach is to sort of do that reactively. So we have some customers who will use things like their backup software, so that when their backup job kicks off, their backup software will hit the API and increase the speed of the link. When the backup job completes, they'll hit the API again and drop it down, so they can really respond to exactly when it needs to be that speed based on events rather than schedules. So all that's possible. You can kind of do whatever you might dream up, I guess, via the API, and then pull all of that usage data and state and metrics back into your own monitoring platforms as well. So in this configuration, I've got labeled here that the VXC is configured to be untagged, which makes that VXC function as a VLAN trunk. So what that means is that any VLANs that arrive at the port on the left-hand side, that traffic will get sent out the port on the right-hand side. So this one VXC will carry any VLANs that you send towards it. And that's pretty common for a data center interconnectivity, because a lot of the time customers want to stretch multiple VLANs between their DCs for various reasons. Maybe they're actually stretching VLANs, maybe they just want multiple interfaces, could be anything. But this configuration, you'd basically have a trunk port on your switch on either end, and all the VLANs that you send out that port will come out at your other data center. So that's useful. A lot of customers want that. The trouble is that if you configure this VXC such that it accepts all VLANs, then you can't have any other VXCs on that same port going to other places. And a lot of the time customers want to have that flexibility, and they want to have that value from the port, that network as a service type functionality, where they don't just want to use this physical port to connect to their other data center, but they also want to use it to connect to maybe a cloud or two clouds, or maybe some service provider. Maybe there's a third data center. could be anything. They want to still have that ability to dynamically bring up connectivity to all those other network as a service locations. But if you have this VXC configured to accept all VLANs, then you can't send any VLANs anywhere else because they're all going to go down this one circuit to your other data center. So there's a couple of ways that you can resolve that if that's an issue. If you do need to kind of combine the best of both worlds. So one option is you just tag the VLAN, right? One option is you tag the VXC that goes between your data centers as one VLAN, and then you can create other VXCs that go to other places that are delivered as other VLANs. So this is really straightforward, but the caveat here is that now you've got one VLAN between the data centers. So now you're only pushing, in this case, I've got, as an example, VLAN 100. If you send traffic tagged as VLAN 100 out of your switch port towards Megaport, it'll go to the other DC. Traffic marked as VLAN 200 will go to the other location, and 300 and 400 and whatever, up to 100 VXCs on the port. But it's one VXC per destination, basically. One VLAN maps to one VXC, maps to one destination. And that's fine. And some customers do this. But as I mentioned before, sometimes customers need to be able to push multiple VLANs between their data centers as opposed to just one. So how you can combine this to go a step further is you can add multiple VXCs between the same destinations. So it's totally possible to create additional VXCs between the same two ports for additional VLANs. The advantage of this is it means that you can specify the bandwidth independently for each of these VXCs. So for example, in this diagram, maybe VLAN 100 is your production traffic, and maybe it needs to be, 8 gig per second sort of thing. And then maybe VLAN 300 is out-of-band management or some other type of service. Maybe it's a path for your backups or something like that. And so maybe VLAN 300 needs to be only 100 meg per second, or maybe VLAN 300 can be 1 meg per second all the time, except for a few hours on a Friday night when it's 10 gig per second for your backup window. So you can manage those bandwidths independently. So that's an advantage of that. It means you can kind of reserve bandwidth more easily over the paths. The caveat here is that while this works well if you have a small number of VLANs, if you needed to push, say, 100 VLANs between your data centers or 1,000, this starts to get a little bit unwieldy and kind of eventually becomes pretty expensive if you're talking about very large numbers of VLANs. So the last option is to use QinQ. So basically, QinQ is a network standard basically that allows you to run multiple VLANs, or more so, it allows you to run multiple levels of VLANs. So how it works is with a normal VLAN, you have the packet, you have the frame, and you put a header on top that says what VLAN ID it is. With QinQ, you do one lot of .1Q, one lot of VLAN headers inside of another. So you can have your packet, you've got one VLAN header, and then on top of that, you've got another VLAN header. So you've got a set of VLANs, you can run VLANs inside of another VLAN. So in this case, on the example, in the diagram here, I've got VLAN 100. So the VXC being delivered to the port from Megaport is VLAN 100. But then within VLAN 100, you're using QinQ to push up to the full 4,096 VLANs again within that. So this allows you to run multiple VLANs over the one private VXC, but also have multiple VXCs delivered to the port. So this is kind of the best of both worlds. There's no additional cost or anything for the additional VLANs running over the private VXC, and you can have the full set of 100 other VLANs to other locations. So this really gets you the best of both worlds. The caveat here is that your equipment needs to support it. So in this case, your hardware on both ends, your switches in the data centers need to support QinQ, and you need to sort of do the config for that. It's not particularly difficult, but it is a little bit more configuration than just using a single level of VLAN tags, and not all equipment supports it. But if it does, then as I mentioned, you can kind of get the best of both worlds. So those are really the options. So you've got either you use an untagged VXC, in which case it's just a straight trunk, one port to one port. You can push multiple normal VLANs over it, or you can use a VLAN, a VXC per VLAN between the data centers. So you get more control over bandwidth, but you're kind of limited as practically as far as how many VLANs. A few is fine, but lots is probably not. Or you can use QinQ. So you get the best of both worlds. The caveat is that you need the hardware that supports it. So we'll jump into the portal and run through a demo. So this is the portal. This is the dashboard here. We can kind of see some numbers here for the amounts of data centers that are in those particular locations. So we'll jump over to the services tab. We'll order a port. So we'll choose a random data center here. So, I mean, let's say maybe 5GN in Melbourne. We'll choose a speed for the port. So we've got 10 gig available everywhere. Some places have 1 gig. Quite a few places now have 100 gig available also. We'll go 10 just for the sake of the demo, and we'll call this DC1. So this will be in our example customer here. This will be their first DC, their primary DC. We'll go add port and order now. And that's pretty much the whole process to order a port into a data center. So we'll now create another port in another data center. So we'll go Australia, and maybe, let's say, where's something interesting? Let's say Odyssey in Adelaide. And we'll choose 10 gig. And we'll call this DC2. Next, and add port and order. Okay, so those two ports are deploying at the moment. Usually takes about 60 seconds for those to deploy. And once they're deployed, you can create circuits to wherever you need. So what we'll do initially is we'll create a circuit between these two ports, right? So we've got a port now in our Melbourne data center, a port in our Adelaide data center. We'll go add a connection. We'll choose private VXC. We'll choose the only other destination that we've got in this account at the moment, our other data center. We'll go next. Let's call this private VXC1. And let's say that we want this VXC to be 2 gig per second. And let's say that we're going to start with that initial architecture where we've got this untagged on both ends. So next, add VXC, order, and order now. All right, so those two ports are now provisioned and ready to go. As far as the data center connectivity itself physically, you can download the LOA now, provide that to the data center so that they can run the cable from your rack to plug into us within those DCs. So that's all done and ready to go. The circuit between those DCs is now being provisioned as we specified. So 2 gig per second at the moment, and untagged. So basically the result of this is that first architecture that we looked at, where we have, jump back up here, we have this type of architecture. We have a port in one data center, port in another, a link between them at the speed we specified, and it's untagged, so it'll accept all VLANs. So if we go into the configuration of this VXC, we can see that configuration here. So we can see that this is the speed we've got configured, and we can change this speed to whatever we like, whenever we like, as granularly as we like, and then hit save, and that'll apply. And we also have this this option here to modify the tagging of the VXC. So once it's deployed, this will let us basically modify the VXC to be either tagged or untagged. So untagged could be somewhat hard to parse, but basically untagged means it'll function as a trunk port. So untagged means the VXC itself is not delivered as any particular tagged VLAN. It'll accept traffic that's tagged as any VLAN and send it to the other end. All right. So what we might do, just as an example, is we'll create a third port in another data center. Actually, let's go somewhere else. Let's go Singapore, for example. We'll go 10 gig again. Okay. And we'll add a connection here. Actually, let's create another port and let's go New Zealand. And let's go Chorus in New Zealand. 10 gig, and let's call this DC4. Okay. So now let's add a connection between these two data centers. This time, let's private VXC2. And this time let's specify a VLAN. So let's specify that we want this to be delivered as a tagged VLAN, as VLAN 100. Okay. And we'll say that this one can be, let's say, 500 meg per second. Okay. And so we'll hit order and order now. So now we're going to order both of those ports and the VXC at the same time. And you can see that with the original ports, because this VXC was configured as untagged, we couldn't order any other VXCs. We can't add any other services to this port because this one circuit is already configured to accept all VLANs. Whereas with these two here, we can add additional circuits to other places. We can add additional VXCs that have different destinations or the same destination. If we wanted to run multiple VLANs between the two ports, we could. If we wanted to run a VLAN from one of these ports off to AWS or Azure or to a carrier, maybe for an internet service, or we wanted to connect to our internet exchange or to one of our kind of routing or firewalling products or anything like that, we can add additional services to these ports because that VXC is delivered as a tagged VLAN. Whereas these ones we can't because that VXC is untagged. And that's kind of, that's getting back to what I was illustrating here. So the DC3 and 4 is configured like this. So we've got that VLAN tagged as VLAN 100, and we have the ability to add additional VLANs as we need. All right, so that is pretty much it. I think what we might do just to illustrate the point here is create another private VXC. So let's call this private VXC 3. Let's make this one, let's say 6 gig per second. And we'll assign this VLAN 200 and VLAN 200 on both ends. So probably something else to point out here is the VLAN on each end doesn't have to match. Most of the time, customers prefer to use the same VLAN on both ends because it makes it easier for them to manage internally. But if you do need to, you can remap those VLANs. So for instance, the traffic that comes in on VLAN 100 in data center 1 might exit as VLAN 200 in data center 2. That's totally fine. Sometimes there's good use cases for that. So we'll go next and add VXC and order. And you can see here in the background that we now have 2 VXCs coming off of each of these ports. So we've got 2 VXCs running between those locations, whereas these ones down here, again, because it's untagged, we can only have a single VXC. All right. So that was the demo. That's pretty much it. Unless there were any questions from LinkedIn. Dave, if you want to.
Not that I can see. I think
All
we're
good.
okay for LinkedIn.
All good.
We've had a couple of comments in the Zoom, but no questions as
Yeah.
far. So I think we're okay, right?
All good. Okay. All right. Yeah, well, that's it for this week. If there are any questions, feel free to throw them in on LinkedIn or on Zoom. Otherwise, feel free to reach out. Um, we have these discussions pretty often. This is a question that comes up pretty frequently. And as I said, it's definitely worth bearing in mind that this is, it might seem like a really obvious use case, but sometimes customers are very focused on the cloud connectivity part. And really the way to get the most value is to use the port for the most things. So you have this port, once you have this connectivity to that network as a service ecosystem, really the value is in being able to use that port for lots of different things. So we have customers who'll have a port connected to us, and they'll have it connected to multiple cloud providers, maybe a service provider for an internet service, maybe our internet exchange for peering, all kinds of different things, as well as their connectivity between DCs. So you don't have to replicate this service from multiple different carriers. You can kind of get the most value out of that connectivity by leveraging that ecosystem and using that port for all kinds of things. Once it exists, it's very often the case that customers will find other use cases. They'll find that other entities that they work with, other businesses that they connect to or they receive connections from, either their customers or suppliers or B2B partners and things like that, will already have Megaport in place. So it's really easier to just add that additional connectivity to these ports as you go. And that's really the goal, is to try and maximize the value, to really leverage the ecosystem to get the most value out of the services that you have. Cool. All right. That's all for today. So yeah, like I said, any questions, feel free to send them through. Otherwise, feel free to reach out either to your account manager if you're already a customer, or if not, via the website. It's probably the easiest method. If you're not already a customer, we'll leave a comment on LinkedIn, and we'll try and cover that in the next drop in next week.
Cool. Thank you, Ryan. And a big thank you to all of our attendees and viewers watching live on LinkedIn and also via Zoom. Great job, Ryan. We'll be back here same time, same channel next week at 12 p.m. As Ryan mentioned, you can register via the website or via LinkedIn. We'll see you all then. Have a great weekend.
Thanks.